Hello, today I'll be talking about Cramer's rule, which is a way of using matrices to solve systems of equations like this one. So first thing we have to do is get this to look like a matrix. So just copying the coefficients, 3, negative 5, you should have a column for the x's, a column for the y's, and then a column for whatever's after the equal sign or your constants. So our second row should look like negative 2, 1, because there's nothing in front of the y, and negative 3. Cramer's rule uses the determinants of 3 or 4 different matrices to solve for x and y. The first thing you do is find the determinant of this original matrix. So we have D equals the determinant of 3, negative 5, negative 2, 1. Okay, so we're finding the determinant of this 2 by 2 matrix, which is just 3 times 1, so 3, minus negative 5 times negative 2, which is positive 10, so 3 minus 10, which is negative 7. Right? That's going to help us find x and y. Now we have to do the same thing for 2 more determinants. These determinants are, say, d sub x equals, now what we do is we take our constant column and we replace it with whatever we're solving for. This is where our x column, this is our y column, this is our constant column. So we're taking our constant column and replacing it with the x for this one. So we have 8, negative 3, and this one stays the same as what it was before. Okay, so we have 8 times 1, which is 8, minus negative 5 times negative 3 is positive 15, which gives us negative 7. Alright, and then the last one, dy, same thing, just replacing the y column with our constant column. So we have 3 and negative 2 stay the same, and the second one becomes 8 and negative 3. And we're just finding the determinant of that, which is negative 9, because 3 times negative 3, negative 9, minus 8 times negative 2 is negative 16, so we're adding 16, which equals 7. Alright, so our final answer for x is just dx divided by the original determinant, which is 7, negative 7 divided by negative 7. So x equals 1. And y is just dy over the determinant, the original one, which is 7 over negative 7, which is negative 1. So that's our coordinate point. X comma y is 1 comma negative 1. Alright, now I'm going to use Cramer's rule to solve three equations with 3 unknowns. So this time we're solving x, y, z. So take this, make it into a matrix. So we have 1, negative 2, 1, 4. Second one, 3, negative 4. Don't forget any of the negatives because this is a lot of work, and if you mess up early, then you're going to have to redo it. It's not going to be good. Third row is 2, 1, and 0, since there's no z, and 9 follows. So, dx, or just regular d for now. We take the original matrix in here, and we're finding the determinant. Alright? There are a lot of different ways of finding determinants. I use a specific way, just copying this under itself. We only need the first 2 rows. So for our original d, we have 1 times negative 4 times 0, which is 0. 3 times 1 times 1, plus 3. 2 times negative 2 times negative 6, that's 4 times 6 is 24, positive because there's 2 negatives, minus 1 times negative 4 times 2 is negative 8. Negative 6 times 1 is negative 6. And then we have 0 times anything is going to be 0. So our D equals 27 minus negative 14, which gives us 27 plus 14 is 41. Alright, now we have to find dx. Alright, so dx, then we have to find dy and dz as well. Dx is going to be take this same matrix, except we're replacing our x column with our constant column. So we have 4, negative 4, 9, which was our constant column. We're just replacing the x. Negative 2, negative 4, 1, 1, negative 6, 0, and we're finding the determinant of that. So we have 4, negative 2, 1, negative 4, negative 4, negative 6. And we're finding the determinant. So we have 0, because that's multiplied by 0. Negative 4 times 1 is negative 4. 9 times 2 times 6. 2 negatives make positive. 6 times 2 is 12. Times 9 is 108. Minus 1 times negative 4 times 9 is negative 36. Negative 6 times 4 is negative 24. And 0. So our determinant for the second one is 104 minus negative 60. So 104 plus 60 is 164. So far we have dx, or we have the regular d and dx, which I'm going to copy down over here because I need more room to do dy and dz. D is 41, and dx is 164. So now we have to find dy and dz the same way. For dy, take your original matrix and replace the y column with the constant column. So, out of the first two rows, we have 1 times negative 4 times 0 is 0. 3 times 9 times 1 is 27. 2 times 4 times negative 6, that's 8 times negative 6 is negative 48. Minus 1 times negative 4 times 2 is negative 8. Negative 6 times 9 times 1 is negative 54. Negative 54. So we have negative 8 minus 54. Write that a little bit neater. And 0 times anything is 0. So we get 27 minus 48 is 21, negative. Minus negative 8 minus 54 is negative 62, which gives us 41. So dy is 41. Alright, now we have to find dz. So we copy our original matrix, 1, 3, 2, and the only thing we're going to change is we're going to take our z column, which is right here, and replace it with the constant column. So we find the determinant. And that's going to become 1 times negative 4 times 9 is negative 36. 3 times 1 times 4 is plus 12. 2 times negative 2 times 4, negative 4 is positive 16. Two negatives make positive 16. Minus 4 times negative 4 times 2 is negative 32. Negative 4 times 1 times 1, negative 4. And 9 times negative 2 times 3 is negative 6 times 9 is negative 54. Okay, so now we pretty much have our DZ. 16 plus 12 is 28. Minus 36, negative 8. Minus, here we have negative 36 minus 54 is negative 90. So we have 90 minus 8, which is 82. So DZ is 82. Now once you get good at this, this is actually a pretty useful way to solve matrices like this, and even 4x4s. So now we take our d, dx, dy, and dz, and we can find x, y, and z using those. We know x is just dx over d, y is dy over d, and z is dz over d. So we get 164 divided by 41. So x is 4. For our second one, we have 41 divided by 41. Usually it's going to work out pretty nicely too. It's 1, and then dz is 82 divided by 41, which is 2. So we have our ordered pair is 4, 1, 2, which is the solution to our original system.
May I have your attention, please?
You can't do something more creative?